Hi everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events. This is one of such events. Actually, this event should have happened last week, but we moved it this week. So you can find out more about the events we have using the link from the description. Then, of course, don't forget to subscribe to our YouTube channel and join our Slack community. During today's presentation, you can ask any question you want. So there is a link in the live channel, in the live chat. So yeah, please use it for asking the questions, and then after the talk, we will cover these questions. I think that's all from my side. And now, Padma, the floor is yours.
Yeah, thanks, Alexei, for having me in. It was a pleasure talking on Data Talks Club. In fact, I have been following Data Talks Club over like past couple of years. The content that you post is very exciting.
Thank you.
Very live discussions on the Slack channel. Okay, let me share my screen. Hope all you can see my screen.
Yes.
Okay. Thanks everyone for joining the session on helping people get jobs with data. Little introduction about myself. I am Padma, the senior manager of data team at Indeed for Enterprise Data Analytics Group. A brief overview of like how I have been gotten into this journey of data platforms, building data platforms, data ecosystem is that I have like overall 11 years of extensive experience building data platforms, scalable ML solutions. So started in 2011. I was primarily working as SQL developer and some of the tech stack like SSIS, SSRS, and then in 2013 I moved to a research role, primarily working as software engineer on distributed systems. So way back in 2013, we as a group of team started developing distributed deep learning over Apache Spark, which was like the initial days of Apache Spark. So exciting days. We sort of iterated over a lot of research papers, and then we were like the first team to sort of build that system. And in later stages of my career, like I worked with organizations like Amadeus, Fractal, Expedia, more of airlines and travel companies, building data platforms and solving some of the business problems with data, especially with knowledge graphs, is one of the crucial areas where I was primarily working on. So today, I would like to keep the content very simple. Outline of the talk would be like, especially in the recruitment industry, given in the phase of post-pandemic, how things have been changing, how at Indeed things have been moving as a two-sided marketplace of serving job seekers and employers, and how data is essentially helping people get jobs is the whole theme of the talk. And I will give you a brief impact that is driven by data analytics teams, what sort of cloud environments that we would enable, what's the data ecosystem looks like for us, and what are some of the cool observability pipelines that we have built, bringing in resiliency and fault tolerance for some of the ETL work that we have been constantly doing. So a brief introduction, like as you all know, like Indeed is one of the globally #1 job search platform. So we are like almost 17 years now, operating in 60 countries, and like our unique visitors is around 250 million unique visitors is what we see on our platform. And we globally serve around 3 million plus employers or clients, you could say, ranging from small, medium business clients to enterprise clients. So at Indeed, like the post-pandemic things have changed a lot, because recruitment, all in all, you could even sense how the whole remote work has changed us, how work from home is sort of bringing new challenges in the hiring industry. Okay, so there have been new doors or new opportunities opened in terms of, how could we leverage that market of people looking out for flex jobs or part-time jobs, or like companies just going remote all the way. Okay, so there are a lot of signals or like business touch points, like is where recruitment industry is trying to ramp up, and this is all sort of fueling the data analytics space, especially in job search platforms. So given that context, so what we as a part of data analytics team are trying to bring in is, earlier like the scenario was like you look for a job when you have a need and you apply for it and you get a job. Okay, the whole in our vision is to make go closer to the hire as much as possible. So to realize that vision or mission, I mean, with the preferences of the job seekers changing so rapidly, there is a lot of emphasis on augmenting new data sets like behavioral data, like hiring trends, labor market data. And all these are sort of fueling like how the job search market is evolving, how consumer preferences have been changing, and essentially how can we meet the demands of the employers or clients in this rapid phase of evolving nature what we see. So we at Enterprise Data Analytics, as it suggests, like we are very much data-driven team. We are like spread across different locations geographically, like US, India, and Dublin, Ireland. So we heavily invest on data platforms, building, new capabilities that would address some of the business groups like marketing, sales, automating the advertisement systems, candidate delivery platforms. So all this function is like driven by data analytics groups, like with the metrics or the value that bring onto the table is sort of serving a lot more business functions in Indeed. So in our group, like we, coming to the technical capabilities, how we are sort of structured, we have like data engineers primarily working on building ETL pipelines. We have software engineers, sort of developing backend applications, tools that would integrate our self-served analytical capabilities into client-facing systems. And then we have data scientists and ML engineers, like primarily working on, trying to bring the behavioral data of job seekers and searches that are happening on Indeed into a co-located space and trying to extract as much value as possible. So coming to the operating model, like where we exactly host our platforms is very much, on-prem and hybrid cloud environment is what we choose. So Indeed like has heavily invested on in-house technologies like Imhotep, Osiris. Like these are like some of the coolest technologies that the organization has built for over decades. And most of the infrastructure is on-prem, like for quite some time. And now, given the faster accessibility needed across business groups, we have been incorporating the multi-cloud environment. One is like obvious reasons for moving us to cloud. Like we are currently leveraging GCP, Google Cloud Platform, and Amazon Web Services, AWS as well. So due to multiple reasons, I mean, we have like heavily invested on infrastructure teams, taking care of the whole infrastructure of the group. But given the analytical space, essentially, if we need to sort of provide the value out of the data to business analysts or any product crews, groups, in an accelerated fashion, we need to sort of deploy things on cloud. And security as well is, we would want to abstract it as much as possible from, the way we sort of develop the solutions is, like we are sort of identified that operating model across infrastructure teams, analytical teams, and data governance teams to essentially accelerate the deployment, develop solutions, and sort of identify the consumable patterns, accessibility patterns for BI leaders, BI analysts, and other business groups, so that the value could be extracted as much as it could be, minimizing the emphasis on infrastructure or security governance, automating the, essentially like the issues that we face with the deployment challenges as well. We are sort of a team who believe in bringing that excellence to, excellence to the problems that we essentially see, whether it is in terms of deployment or data discrepancies we sort of identify on a day-to-day basis. We are sort of a team who constantly innovate on the solutions, build like observability pipelines, or like resilience that we try to bring into the ETL pipelines is what we constantly evolve on, ensuring that we have the right data to the right people. That is sort of trying to bring the value out of the assets that we deploy. And there is this very much a shared collaboration across the teams, as I said, like infra, data scientists, ML engineers, data engineers, BI analysts. We sort of introduce this whole model of, improved collaboration, so that teams are aware of what is happening, beyond the reach. Like if there is any sort of ETL failure that is essentially sort of occurring, we have a shared communication that is being given as a, as an indication or as an alert to the downstream application, so that risks could be mitigated as much as possible. So as I was quickly stating, this is like the overall our data ecosystem would look like. So we have like heavily invested on the in-house infrastructure tools like Imhotep, Osiris, Log Repo. These are some of the technologies that Indeed has built over years. And so far we have been trying to get the data onto on-prem cluster, and serving the analytics from on-prem cluster was a nightmare. There is a lot of engineering involved, and by the time you resolve the issue, the analysts or like the BI teams wouldn't have shown so much of interest in extracting that value, because like there is so much of emphasis on resolving the infrastructure issues. So what over years, like what we have done is like past couple of years, we have been heavily investing on cloud environments. So for example, we have the on-prem clusters existing as is, but we have built robust pipelines that bring in data from on-prem to cloud. So at Indeed, as I was saying, like we are very much cloud agnostic. If teams prefer like some of the tools being widely used on Amazon are like very much serve the purpose, we also use the Amazon tech stack. If that's not the case, if Google BigQuery serves the purpose, we put our assets on GCP. Okay, it's very much multi-cloud environment that we choose, and essentially our pipelines have the capability of bringing data, cross platforms, whether it is on-prem to GCP or GCP to AWS or AWS to GCP. Similarly, like we have like real-time Kafka pipelines, that's something again on-prem. It's all driven by Kubernetes clusters, and then we sort of built that ETL capability, which can stream in the data to GBQ. primarily as of today in enterprise data analytics group, we have been sourcing data from GBQ, and from which different teams sort of consume it. Like one of the essential tools we use for building data models is DBT. Okay, like all our warehouse engineers sort of use that technology very widely. So there is so much less emphasis on code. It's very much a SQL script that you can build. And coming to the access patterns, we try to evolve as much as possible. It's not only analytical access patterns through tables or views that we serve our customers. It's very much like API first strategy that we're trying to bring in. Providing accessibility to not only to a single group, but of course across groups in Indeed. So we also quite a well leverage like reporting tools, as you all aware. And when it comes to the data science workflows, we are sort of researching a lot on leveraging ML flow, cube flow, and other model registry technologies, which could automate the onboarding process of a data scientist trying to deploy his model. So the ML ops is kind of going to be a next big thing in our team, because we are sort of building that whole self-served model deployment, not only to the enterprise data analytics group, but for also across engineering groups in Indeed. So this is one of the key interesting topics that I would like to talk about, observability. As you all know, ETL is like quite a big name heard, or like old name heard from long time. Okay, so any ETL pipeline that we sort of build in has an upstream dependency, and this pipeline sort of provides the input to the downstream applications. Okay, so especially in a multi-cloud environment, this has become quite a big challenge for our team. Okay, because we have like pipelines pulling data from on-prem to AWS and AWS to GCP. Like the pipeline is spanning across multiple cloud environments, and the data is provided by different teams. So this was sort of a very tedious task for us in the beginning, because essentially when I'm building a pipeline which is coming from S3 to GCP, which is a real-time pipeline, I just need to track what's the latency of arrival of the data in S3, and what's the latency by the time it is pulled into BigQuery. Okay, and what is the latency when I run my DBT model on top of it. Okay, this whole sort of journey tracking, the whole pipeline spanning across environments is quite a complex challenge that we have dealt with. So this is one of the essential integrated Datadog monitoring that we have built. For example, people might have heard about instrumenting the applications, especially the web applications with Datadog. But what we have done in our case is even we are able to instrument the Spark jobs, okay, which are like batch jobs, which is quite an innovative stuff. So we have integrated with Datadog libraries, we have instrumented it. I mean, essentially, if Datadog's metrics collection would really do the job of being able to report the errors. But in our case, since our pipelines are being built on multiple, spanning across multiple environments, tracking the latency, okay, how much time it essentially took over 7 days, or like last 20 days, is that sort of analytics I want to do, and real time alert the users when the pipelines are sort of failing. We have sort of instrumented these Spark pipelines with the instrumentation libraries. And so this is one of the views that I would like to provide here, where if you could see, for one of the pipelines, like which is bringing data from on-prem to GCP, from one of the data sources, like we sort of providing the whole duration, what's the start time and end time. Okay, so let's say if it is scheduled, like some of the Spark jobs are scheduled through our in-house orchestration tools. Even if that's the case, we are able to track whether the issue is with actual in-house orchestration tool by the time if it is running out of time in launching a Spark job, or if the issue is directly with a Spark job. Here you can see on the right side like different spans that try to capture like when the orchestrated has started versus when the Spark job has started. Okay, so which essentially shows that there is so much of lag in by the time the Spark application is actually started. So this gives us a way forward to really look at the cluster stability. Okay, to really sort of interact with the infrastructure folks to try to understand if this lag is sort of increasing in time, if the cluster needs to be scaled out, or if we need to understand the root cause. This sort of analysis is really helping us as of today. Okay, so I could just get the stack trace of any failure that I receive. Okay, and we have integrated this into Slack alerts as Slack alerts, so that people are just aware of the failures that are happening, and they're cautious enough, and accordingly the decisions have been made, and we sort of inform this to the downstream applications or the data scientists who are leveraging the data sets. So much to talk about distributed tracing and data observability in the coming talk. I would like to give different scenarios of instrumentation that we did for real-time replication with Kafka, replication that we did from S3 to GCP using Amazon SQS and other tech stack. So there were like different scenarios that we have handled in especially the observability side, that I would like to have that conversation very in detail. So having said that, so in our data platform stream, like there are like exciting times coming ahead. So we have been building a lot of automated tools with sophisticated technology that would ease the job of data scientists and ML engineers. I mean, if you're sort of a person who would like to understand the ecosystem of enterprise data analytics team, and have interest in understanding what we do, what are some of the business problems that we solve, I mean, like I'm happy to chat, and please drop me a note on LinkedIn. So that's all from my side.
Thank you. So you should send me your LinkedIn, so I will include this in description. So yeah, we have a couple of questions. So the first question is, I want to ask it. So you mentioned you have this on-prem cluster. Why do you need this? And like, is it expensive? Do you consider getting rid of this, or it's actually useful for you, and there is a very important reason why you need to keep it on-prem?
Yes, there is an important reason for us to keep it on-prem, because there are some of the tools that Indeed has built in-house. Like for example, Imhotep is one of the indexes that Indeed has built in very early years. Okay, so Imhotep is a sort of a tool which is exactly what Elasticsearch does. Okay, and today, as of today, when we see most of the activities that are happening on job seeker side or on employer side, or that gets available as a data source in Imhotep. Okay, so since these are all like in-house tech stack that it is built around, we have like very much relied on on-prem. We have like pipelines bringing data from this Imhotep data sources to Hadoop clusters. Okay, and since like the phase of the whole company is changing, we have to accelerate the way we build analytics. So we have been trying to accomplish this by bringing cloud environments, and then effectively build pipelines that bring to cloud, and then do faster analytics.
And I think I saw on one of the screenshots that it was a Spark job that you run on GCP, right, on Google Cloud Platform. And then you also use Spark on your on-prem cluster, right? So you have some jobs that you run on your Hadoop cluster, right? And then you have some jobs that you run in the cloud. Is it correct?
Essentially, as of today, we are just running Spark jobs only on on-prem. So that job that you have seen is like on-prem. It's like orchestrated through build orchestrated, which is very much again our own tool that we developed, and it runs on-prem, but it has connectors to GCP to bring to GBQ.
Okay. So you run, so the raw data is in your HDFS, right? And then you process this data and then you push this to BigQuery, right? Or where do you? Okay. And then there are then you have models in dbt, you have other things that take data from the data warehouse and do extra processing, right?
Yeah.
Okay, clear.
That's correct.
Okay, and there is a question from Jefferson: is why do you use two clouds?
It's actually specific to team, and the choice that is made with respect to how accelerated way we need to go, and some of the tech stack in GCP is very good, especially the BigQuery side. It's essentially very fast, and when we are sort of developing some of the ML models for sales teams, we essentially were in a phase like we need to provide the outcomes as quickly as possible. And especially if someone coming from non-tech background like sales or customer success teams, if they want to leverage the data sets, I mean, BigQuery was way too fast, compared to putting in S3 or RDS and then talk about the analytical access patterns. So it's again like we are very much open. Okay, if we see that like in GCP, like some of the tools can be are way more beyond what we see in AWS, we would essentially use that capability. Okay, or otherwise, if AWS has, let's say, some of the tools like SQS, Lambda is AWS is far more better in event handling scenarios, is where we sort of leverage the AWS tech stack and tools. Yeah.
So from AWS side, you use Lambda, you use SQS. What else do you use there from AWS?
CloudWatch and SQS and S3. Okay, so we are sort of also comparing Redshift and GBQ. Okay, essentially we will try to analyze as a platform team. We are sort of analyzing the pros and cons of Redshift versus BigQuery. Okay, I mean, if all goes well, we are also putting that effort to move from BigQuery to AWS.
Okay. But I saw a few comparisons online. I haven't done this comparison myself, but usually when you compare BigQuery and Redshift, Redshift is not, let's say, favorable usually. So I see why you have this.
I mean, we have like teams using Snowflake as well. Okay, we have like some teams using Snowflake as well. Again, it's sort of we are sort of collaborating on that front to identify, because the business groups that different teams serve are different. Okay, so getting everybody onto the same page is sort of a communication and what we need to prioritize. We are also looking on the Snowflake front as well. If Snowflake is the next data warehouse which we could rely completely on.
Clear, thanks. And then another question I have is about your in-house orchestration tool. Did I understand correctly that the reason you have it in-house instead of using, let's say, something like Airflow or other orchestration tools is because you have extra functionality? Like you saw this with the Spark job. So first there is some, I don't know, idle state, and then the actually job starts. So you have this nice chart. And other tools do not have it, right? That's why you rely on your internal tool for that. Is it correct?
So it's way back built, the build orchestrator when Airflow was not open sourced and all.
Mm-hmm.
So these are some of the legacy systems I would say. I mean these are very nice tools. So build orchestrators generally tries to orchestrate any batch job, whether it is MapReduce or Spark, okay, and it effectively does the resource allocation and ensures that your jobs are running in the cluster. So I mean now we're in a state of leveraging both, okay, Airflow and on-prem. Most of the on-prem stuff is still we do with try to do with in-house tools, and then once we try to bring into cloud, whether it is AWS or GCP, the next set of ETL pipelines are mostly scheduled on Airflow. Yeah, it's a mix of tools that we try to work on.
And now I will share my screen because there are more questions and maybe it's easier for you if you just read. So this is YouTube. So another question from Jefferson is why you use dbt for transformation and not BigQuery itself together with Airflow?
So dbt is a very good tool for basically, let's say, in BigQuery, I mean, you can schedule queries and then you can write scripts to build the tables and views. But essentially, when you're talking about building fact tables or dimension tables, okay, the right data model is what you want to identify. Then dbt is a very highly sophisticated tool because it's all SQL script, and one of the out of the box benefits it provides is the lineage. Okay, let's say my data model or dimension or fact table that I designed is dependent on, let's say, 10 sources. Okay, so it sort of has that advantage of tracking the lineage, and you can easily debug if my rows have any null values or like discrepancies. I can just backtrack the lineage and figure out what the source that is the culprit, and my job becomes very easy on a day-to-day basis.
Mm-hmm. And, so Airflow doesn't have this, and BigQuery, I guess you use dbt for executing queries against BigQuery, right? So you use BigQuery.
Yeah. So we bring the raw tables to GBQ, okay, and then staging layer, and the way we structure it is bring it to staging layer, and then we have a production database. And this is like the raw data, okay. Now let's say I need to build a data model for customer success team, combining job seeker data, employer data, like maybe 10 other different sources. So my warehouse engineering team primarily works on designing that data model. Okay, what data model works, what's star schema or like a snowflake schema that I need to put into place. That's once is iterated and decided, that's when I put in dbt to come up with my dimension and fact tables. So it's scheduled through dbt, the final dimension and fact tables.
Yeah, makes sense. Thanks. So a question from Anand. So for MLOps, do you use MLflow to retrain models in case of data drift, concept drift? Can you please tell us more about this process?
Yeah, for MLOps, so we have been using MLflow for experimentation cases. So when the team was like really small, like 4 to 5 data scientists, we were much doing it in ad hoc fashion. Okay, now that it is growing, like we have brought in the concept of versioning and experimenting. Okay, so for retraining as of today, I don't think we have been leveraging MLflow, but essentially, like once it's retrained and the analysis is done, what version of the model is available is like tracked through MLflow. So the experimentation, the data set is like all tracked through MLflow.
Yeah, to be honest, I don't know if it's actually possible to retrain models with MLflow. So for me, maybe it has this functionality because it has quite a lot of things. But to me, first of all, it's a model registry and experiment registry.
Yeah.
So this is things. So they are retrained somewhere, not in MLflow, and MLflow just keeps the
exactly
the results, right? And then for detecting drift, do you have anything maybe built on top of Datadog or something like that, or you only have this for data observability?
The ML flow and Datadog you're saying?
No, like, so there is a part of the question about data drift and concept drift. So you mentioned that you have this data observability part where you use Datadog, right? Do you have something like this, but for ML ops side of things? Like, I don't know,
So
AI observability?
the observability pipelines is not specific to ETL pipelines, but for the data scientists as well. When they are sort of using the data assets, the same pattern is applied for the ML engineers, like integrated into Datadog, and it sort of alerts on the drifts. Okay, that integration is way more statistical compared to the observability that we do for ETL pipelines. It could be just null checks or like capturing the errors. But in ML models case, the data could be all good, but like integrating the root cause analysis. Okay, what's the percentage drop in revenue statistically, whether it is significant or not? Okay, that's all metrics are integrated into Datadog for alerting purpose. But where do we get those percentages, like whether this is statistically significant or not? That is from the data scientists.
And I think it's been a while since I used Datadog last time, a couple of years at least. But I remember they had this anomaly detection part there. So you can just say, okay, if there is an anomaly, send me a message somewhere, email, Slack, or whatever. And this is something we used back then, but it was quite manual. So then instead of automatically doing things, we would just, press a button ourselves.
Yeah.
Okay, so moving on, another question from Anand. In case of MLOps process, in case the MLOps process is yet to be implemented, can you please share how this probably could be done in your case?
I think probably it will be like more to explore. I mean, we have been already in the phase of implementation, but I think, I mean, I can give you a brief overview, Anand. Like what we have been trying to do is bring in the model registry using ML flow. And as of today, when the models are ready, the pickle files are very much integrated into the ETL pipelines in a batch fashion. Okay. As a first step, what we're trying to do is go with API first strategy. Any ML model a data scientist is trying to deploy in production, like generate the boilerplate code for them, and then expose REST APIs on top of your predict function. And these APIs are then leveraged by ETL teams to basically consume the predictions, or when you need to predict in real time, like on larger data sets. Okay, so this is in a very nutshell, but that's the overall idea. But in order to scale it at an infrastructure level and spanning across different teams, we have been trying to move it in a very distributed manner. So I think we can collaborate more on this front. If you are interested, you can drop me a note so that we can both chat on that front. Essentially, if you're looking for some hints on, like, suggestions on what tech stack need to be evaluated and all.
Yeah, thanks. Yeah, maybe if you will write something similar to this once you finish it, that would be quite interesting as well. So, anyways, moving on. So how do you merge changes between HDFS and BigQuery?
Yeah, this is interesting. As I said, like similar to Build Orchestrator and Imhotep, we have something known as Watcher, which is like, again, an open source tool. When I say open, not an open source, but like an in-house tool for Indeed, which is again very much on the front of monitoring the changes coming from Imhotep to HDFS. So it is an incremental watcher that is implemented, which is sort of identifies internally what row level changes or a new data set, incremental data has been arrived, and that is sort of integrated with build orchestrator to trigger a job. Okay, whenever the changes happen, that's when a job is triggered to pull those changes to from HDFS to BigQuery. So the name of that tool is IQL Shard Watcher, I would say. I'm not sure if you can Google for
How do you say?
IQL Shard Watcher.
IQL, like that? I don't know if
Yeah,
I.
yeah. I don't think
Aha,
it's.
okay. Imhotep query language. So actually, it found this thing.
Yeah. So it's Imhotep's Shard Watcher. So essentially, it's nothing rocket science. It's a distributed application that we have built. Okay. What it does is it just spans multiple instances, looks for the changes happening in the index, and it reports to the so when it brings to HDFS, that's how the importer jobs are sort of alerted. Okay, so it's all like inbuilt uh, tools which are sort of identifying the changes. The ecosystem is built by us totally, rather than relying on open source tech stack. That's all I
Did
can
you
say.
s- did you say it's open source or I misheard?
The Shard Watcher, I don't think it's open source, but you can get a lot of information on that front in some of the Indeed engineering tech talks. Okay, the way it is built, the way it is sort of identifying the changes.
Okay, probably the link I just shared, this talk, right? Even though
Yeah,
it's
yeah,
a bit old, maybe you have something more recent, but I guess
yeah,
it
yeah.
gives some ideas, right? Okay, so another question from Gagan. So data platform versus data mesh. Any suggestions on data strategy for new teams building data platforms?
I think see, my view is like these two are very convertible. Okay. Essentially, what we are looking as of now is like platformize things, and once we sort of build that whole resilient architecture for platform to for going platformized way, then we are would go to probably in a state we could discuss more on data mesh. Okay, I think as a first time when you're building platforms, the idea you should bring into place is like what's the problem that you have currently, and to essentially make this data consumable for your business partners. How can you bring some of the platform specific components? Okay, whether it is data lake, okay, API first strategy, okay, building resilient ETL pipelines, how do you automate that, self-serviced ingestion pipelines, all that would in first place build a data platform. Okay, and once we have that in place, I think we could discuss more on, elaborate more on data mesh architectures.
But data mesh, if I understand, it's about having multiple platforms, right? Or
Yeah.
is it the main idea? And then you somehow need to figure out how to actually link them. And maybe this is a bit true for what you have, because you have like something on-prem, then you have this data warehouse, and they are like different things. Yeah, I'm still
It's
trying to
a,
understand what this is, what this data mesh is, and where something is data mesh and where it's not yet data mesh.
basically it's a domain oriented architecture. Okay, what people would say is, let's say typically, let's talk about a scenario. I have a recommendations team, I have a sales team, and I have a marketing team. Okay, individual teams coming up with the decentralized data architecture is what data mesh talks about. Okay, um, platformized is like centralized one that is serving all the needs of three product teams. Okay, So it's a combination of both, I would say. Basically, data platforms should in a way enable technology and tools that would bring in the data which can be leveraged across product teams. Let's say, for example, to be specific, clickstream data. Okay, clickstream data is like the common data stream leveraged by marketing, sales, or anyone has has that business value of consuming clickstream data. Okay, team should invest more in coming up with strategies and product technology identifications that would streamline this clickstream. How fast this clickstream could be consumed by multiple product teams. Okay, what's the robust architecture I could look at it? That's the way platform should go about. Okay, and when marketing team is consuming that, in a way it is very specific to marketing function. You are developing ETL capabilities, APIs, consumed by marketing teams, data scientists who are working in marketing team. That's more of a co-located work stream I would talk about. Develop those tech stacks, tools, and capabilities which would bring resiliency for your marketing team in a team as such. Okay, it's interoperable, and I think the first way to think about is like which area you belong to, and is it like specific to business group you are working or platform teams you're working, and that's the way you can build about it.
Yeah, so I'm checking if we have any more questions in live chat. No, it seems we do not, and there are no more questions in Slido. So let me stop sharing the screen. So yeah, thanks a lot. Thanks for joining us today. Thanks for talking, telling us how things work at Indeed. You shared a lot of stuff with us, so thanks a lot. And thanks everyone for joining us today, also for asking questions. And yeah, I guess that will be it. Do you want to say anything before we finish?
Thanks, Alexei, for organizing this talk on a very quick note. Hope to have more sessions on Data Talks Club, more tech-oriented talks. I would like to have in collaboration with the team. Yeah. Thanks everyone for joining. Yeah.
And please send me your LinkedIn. I will put this in the description. So if somebody is interested in your job, in jobs that you have, that they can reach out to you.
Yeah, sure.
Okay, then that would be it, I think. So have a great rest of your day, everyone. Goodbye.